Um, but if you're there, I'm Kathy Burnett, and I'm here to talk today about claims evidence reasoning. And this is a technique used a lot in science, which is where I'm using it. And it is a way to kind of go beyond just having kids make conclusions. So, my students, and I'm a middle school teacher, and um, my kids have trouble trying to make conclusions. They just kind of say, "Oh, well, this is what happened," but they don't really analyze what is it and what does it mean and who cares. So I've started adopting this idea of claims evidence reasoning, and basically what it is trying to help students become better scientists because this is really the way scientists think. And they certainly need to make a claim, they need to make a conclusion, but how do you go past that and actually have them back that up? So and just say, instead of saying, well, we're going to test to see the impact that a rock makes when it's dropped from a certain height. So that's great. They say, oh, well, a big rock makes a big impact, and that's fine, but so what? So what does that matter? So what does that have to do with mass? What does that have to do with height? What does that have to do with kinetic and potential energy and force and all that? And that's where they start to bring in their evidence. Oh, well, I noticed when the rock was really big that the impact that it made in the flour or the sand was bigger. Hmm. So mass must have something to do with impact and force and acceleration maybe. And so they start to think and start to put things together. Basically, then a claim is just answering the problem question. So our problem is, why does the moon have impact craters on it? What hit it? Why are they there? And so their claim is the moon has impact craters because. Then their evidence is their data and their observations that support it. So, just like the scientific method, they've gathered data, they've gathered observations, both qualitative and quantitative, and how do they put that to actually support a claim? And then the final part, which is really the hard part, is the reasoning. So, how does that evidence that you just gave me support your claim? And again, this is something that these kids really, truly struggle with. And so it's something that they definitely need to practice, practice, practice. And there's lots of good videos from Bozeman Science that talk in detail about claims evidence reasoning. And so, what does it look like um, when you do it? So one of the things I'd ask is, I had the kids practice this first. So you definitely use some samples that are not really science based to have them practice doing it, just so they get the idea of what I'm looking for when I assign this as something to do. So there's a cute video. It's called "Is My or My Dad is an Alien," and you show it, and it's a car ad. But this little child's convinced that her father is an alien, and her claim, "My dad is an alien," and then her evidence is, well, he's got these different things, and you can watch the video and see it. But dad is able to turn things on with just a push of a button and other things, and therefore my dad is an alien. So I have the kids actually practice with that video. It's only about 45 seconds long. And they watch that video and go ahead and make a claim. Then I ask them, what's the evidence? And oh, her dad's not an alien. Okay, well, she gives you good evidence. Why does she think her dad is an alien? So um, they practice with that. And then the reasoning. Okay, well, what do we know about aliens? Does her dad meet the qualifications? Well, in this video, he does. So that's how I started. And as I said, I teach middle school students, but the strength of this this isn't just middle school. This really should be happening in third through fifth grade as well. And in third through fifth grade, students maybe they're making a claim. They can make a claim. They might have some observations, and they might start getting connections. Whereas in middle school, they really start doing that reasoning. The reasoning is what comes up in middle school. They should have a solid way of answering a claim. They should have a solid way of listing evidence by the time they get to the middle school. Unfortunately, often they don't. So it is renewing or teaching them for the first time in my school. When they leave middle school and they go to high school, they really should have a strong way of creating claims, using evidence, getting the reasoning, and then they add another one. And it's really CERR. And the second R is rebuttal. So a high school student should be able to say a counter claim and explain why the counterclaim doesn't work. So it's not enough to just say my dad is an alien, but to say why proof that he's not an alien. So do the counterclaim as well. And so that's how the kind of the progression of CER should happen as students progress through school. So in other words, it's not just writing a conclusion. Um, so again, going back to that, the idea of okay, the heavier rock or the bigger rock made a bigger impact when we're doing cratering, and the evidence when we dropped two different rocks into the flower, the impact of the heavier rock was larger. Okay, that's evidence. They could actually add the sizes of the rocks. They could add the sizes of the impact. And then their reasoning would be rocks that have a greater mass have a greater force. And that is because force equals mass times acceleration. And there's a direct relationship between mass and force. That's their reasoning. So it's got to be something scientific that they're bringing back to the classroom. But it's not just for labs. You can certainly use this when they're doing a video clip, if they're reading a journal article, if they're interpreting a graph. And graphing is, for my kids, again, is not a skill they're very good at. So they look at the graph and they're overwhelmed by the numbers and the lines and what does it mean and the different colors. So having them make a claim, okay, look at the graph and find one thing that graph is telling us. What is it saying? Why is it? Where's the evidence it's saying that? And what's the connection to a scientific principle that we're studying? So again, why do we do it? Well, it's the way scientists think. This is what scientists do. They don't just say, "Well, this cold pill is going to solve all your problems and going to make you feel better." They have to give evidence. They have to give proof, and they have to connect it to the reasoning. Why does the cold pill work? Certainly, this is in our NGSS under the SEPs, the performances. You've got constructing explanations and designing solutions, so science and engineering, engaging in an argument from evidence, obtaining, evaluating, and communicating information. It's all there in the NGSS. At some point, you've got to teach this, and this is a great way to do it. But they need practice. They need a lot of practice. So what I try to do is tie it to what they already know. I spend a lot of time teaching variables. I have the kids for 3 or 4 years, so I have a lot of opportunity to reinforce variables. But variables work so nicely into CER, independent variables, dependent variables. So I scaffold it. In the beginning, I'll give them the sentence, and I'll say, as the blank, fill in the IV, increase the blank, the dependent variable, did what? And so they just fill in the blank. Okay, as we changed the size of the rock, or as the size of the rock increased, the blank, the dependent variable, the size of the impact crater increased. Perfect. Just a way for them to again start to make these on their own, but with some scaffolding. If they're looking at a graph, I'll say, my graph or this graph shows that when the blank, the independent variable, was at the blank, whatever number, was at the lowest, the highest, the middle point, the dependent variable, fill in the blank, was at the blank. And then I say, and this happened because. And that's where they again start the scaffolding, where they start to actually do some really good CER. If you're doing something with reading an article, you could give them some scaffolding with the text says blank. A pattern I saw was blank. In the lab, I saw blank. But again, when you start doing CER, you can't just say, okay, make a claim, show me some evidence, show me the reasoning, because I tried that and it doesn't work. They don't know. In my school, this is not happening at the lower grades. So they came and they just kind of looked at me, oh, what's a claim? They really didn't know. So it was good. Okay, let's go back. Put up my dad is an alien. They really struggled with that too, I'll be honest. And so we did a couple of other activities to get them thinking in this kind of way that scientists think. Um, if you have them like with a controversial topic, you could have them make a claim and you can say, "What is your position? Do you think this should happen?" We did a CER with whether or not selling organs should be legalized. So their claim was selling organs blank should be legalized, should not be legalized. Evidence. So let's look at what you have to support your claim. Oh, and by the way, what source did you find that information from? Is it something that you um, truly can trust or not? And so let's look at the validity of the source, and then reasoning. How does your evidence justify your claim? I can't tell you how many kids give me a claim, and then their evidence has nothing to do with their claim. We just grew some germs in seventh grade, and we were comparing the size, the shape, the color, and the speed with which they grew of the bacteria and fungus that we found around our school with the ISS. The astronauts on the ISS did the same thing with the agar and grew bacteria. So we tried to make a claim. Do germs grow faster on Earth or in space? And I'd have kids say, germs grow faster in space. And then their evidence was, well, we saw on our petri dishes that we had bacteria at day one, and the ISS didn't have bacteria until day 15. Evidence does not really support your claim. Your claim says it grows faster on the ISS. And you're telling me it took 15 days on the ISS, but it took 1 day on Earth. Something's wrong with that claim. So they really, again, they really, really struggle with this technique, but I just think it's so crucial. Um, so with graphing, so I showed them a graph of the amount of snowfall in Wisconsin, which is where I'm from, and they look at how much snow, just a simple bar graph of the amount of snow in different parts of Wisconsin, and they have to make a claim. Like it snows the most in blank. Well, Minocqua, which is northern Wisconsin, has almost the highest amount of snowfall, about 110 inches. So there's your evidence. My evidence is, I say it snows the most in Minocqua. My evidence is on the graph, it showed that there was 110.5 inches of snow in Minocqua, and nowhere else had nearly as much. Okay, that's great. There's your evidence. Um, well, what other evidence do you have? Okay, let's go to a map. Where is Minocqua? Oh, Minocqua is really far north in Wisconsin. Hmm. So let's get to our reasoning. What's my reasoning? Well, maybe it has something to do with the fact that Minocqua is so far north. Let's look at latitude and longitude. What can we prove that we know happens when you go further north? Again, it's not that hard to us, but it's hard for them to make these claims. Another way I do it is I show an HR diagram when we're doing astronomy. And so I asked them, okay, look at this crazy graph, which is a crazy graph. And what do you notice? What color stars are the hottest? Which color stars are the coolest? And when you look, the first time you've looked at an HR diagram, you don't realize that the numbers on the x-axis go the opposite way. And so it's something they're like, oh, well, the yellow stars are all over here and they must be the hottest because I always know the numbers always increase. Ah, check out that HR diagram. So give me some evidence. What do you know about these colors of stars? What do you know about the temperature? Huh. Can we throw in luminosity? How does that affect? How's temperature do, or does it affect the luminosity of a star? Another example, my sixth graders totally blew this one. I asked them, we were doing genetics, and so we're doing Punnett squares, and we did, all our activities associated with that. So why, or can you make a claim that dominant traits are the most common in a population or not? And so they all said, well, of course, dominant traits are the most common in the population. They have the capital letter. And when I do a Punnett square, they show up most of the time. Oh, okay, so that's some evidence, but can you prove it? Can you find a dominant trait in the population that is not the most common? Oh yeah, there's a lot. Or how about a recessive trait that is the most common? So really push them. They really had trouble with this, um, and you know, they struggle. Well, there's no answer, Mrs. Burnett. Okay, well, maybe there's not. Maybe it doesn't matter. But I did have students who dug deep and found out about one young man found out about Huntington's disease, which is caused by a dominant trait. Well, Huntington's disease is not very common. Well, how can that be? It's a dominant trait. Shouldn't it be the most common? What happens that makes it not the most common? So this really, really pushed him. So yeah, Punnett squares. I love doing Punnett squares. It's a blast. We have fun with genetics and do the genetics of Harry Potter and all that. But why does it matter? And then I really feel like these claims evidence reasoning gets to the why does this matter? Another example, so this one I do in eighth grade when we do chemistry. I have them go to dhmo.org, which unfortunately is no longer a live web page. So I actually made my own um, pretend web page on DHMO in a Google site, and I share that with them. But they have to study DHMO and decide if this chemical compound should be banned or not. And out of my 21 eighth graders this year, 21 of them thought that DHMO should be banned. And the evidence on the webpage that I send them to is very clear. I mean, it's this is terrible. It was used in World War II to kill people. Athletes are using it to enhance their performance. They all sorts of horrible things. It can cause chemical change. Um, it there's a lot of evidence that you should really ban DHMO, and then there's good reasoning that they can get to it. DMHO can make you sick. It can kill you if you have too much of it. It dissolves everything, much better than any other liquid. You can cause an electrolyte imbalance in the body. All these things that DHMO can do for you. Well, very few of them worked hard to find out what DHMO was. And a couple of them got, oh, it's dihydrogen monoxide. Okay. And they didn't think about what does that mean? Di? We spend so much time on prefixes and suffixes. They didn't even think about it. Di. Two. Hydrogen. Okay, two hydrogen. That's one. Oxygen. Huh. Two hydrogens, one oxygen. Sounds an awful lot like water. So that one is kind of fun. It makes them mad, but it also teaches them they really need to look at what their sources are. So again, we had uh, a lot of kids who said it should be banned, or I had a lot, and they said it's been found in cancer cells. It's sprayed on plants and crops. It can make you sick, and a lot of them thought it shouldn't. It could be used as a drug if it was carefully monitored. You could have DHMO, but that it definitely needed to be have some legalization around it to make sure that it was safe. I just yeah. Yeah, one of the kids said, "It's dissolving more things than any other liquids. It could be dissolving your kid's stomachs." It's water. Then we did a friction lab. So we want, does friction always slow down an object? Okay, well, Newton says it does, and that's nice. But let's prove it. So they had to do a variety of different labs with friction and little cars, and we use little pocket labs. If you've never used a pocket lab in your science classroom, I don't work for them, but I highly recommend them. And um, it's just a great way to measure friction and measure speed, velocity. They do all kinds of things with those pocket labs. But the kids studied it, and they came up with some pretty good CER. So one said, friction will always slow down an object. Okay, great claim. A grippier friction like sandpaper slows it down on a flat carpet, whereas a flat surface, whereas a carpet will make it glide better. We found out that the carpet caused the most friction and worked the best to slow it down. And then here's it, because the marble that they were using in this case caught some of the strands and slowed it down, but the sandpaper wasn't sharp enough to slow the momentum. And it says they brought in Newton's first law says an object at rest will stay at rest until acted upon by an outside force. The motion is in this experiment is the slope of the cardboard we had the marble on, and the marble would travel forever if there was no friction. The friction we used is blah, 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 and they listed it. And no matter what we used, the marble always slowed down. Great, great, great. Some of their spelling wasn't so great, but they did a great job. Some of the kids looked at the weight and they said the heavier an object is, the greater amount of force is needed to break the static friction. Okay, because all I really asked them was make a claim about friction. And then they said when we put 200 grams of weight in the mug, it took 1.48 newtons to break its static friction. But when we put 100 grams of weight in the mug, it only took 1.143 newtons to break the static friction. Ah, great. Okay, so now we've got some kind of a evidence that's supporting their claim. Great idea. Again, this was eighth graders, so they've had a little more practice. Although, honestly, they've only really been doing CER for about 2 years, so they've had more practice, but not tons of it. This was again the Newton's first law was proven in our experiment, and then they supported it with looking at Newton. Great, great, great project. Um, another thing is with these assessment ideas and starting to think about assessment and how do you assess their CERs. So one of the ways that I'm trying to move towards more of a standards-based grading where I'm looking less at um, you know how many lines do you have in your paragraph, or did you use a capital letter, and more on did you get the point that I was trying to make. So one of my standards is that they can make a claim for Newton's first law. Okay, so there's my standard. So can they do it? So looking at their claim, their evidence, their reasoning, and giving them on a scale of 0 to 4, or 0 to 3, or 1 to 4, or 1 to 3, can they do this? Can they make a claim that support, and then back it up with evidence that supports that? Those are easy ways to just say, 3, 2, 1. Yeah, they can do this without any help. Two, they can do it, yeah, if I give them a little help. One is why they really need a significant amount of help from me to do this. So, on a one scale, it might say they make an inaccurate claim. No, they get a one. They made a claim, but it's not accurate. They might get a two if they make an accurate claim, but it's not complete. Or a two, or I'm sorry, a three would be they make a claim and it's complete with evidence there to show that they've mastered this. They would have to provide appropriate and sufficient evidence. So instead of having a rubric that says lists 3 ways that you support your claim, well, they have to make that decision. It's possible that one piece of evidence could support their claim and be adequate, but unlikely. They're going to need more than one piece of claim, one type of evidence, excuse me, piece of evidence. The level of a two, maybe that's appropriate, but they have a good piece of evidence, but it's not enough. They need to support it more. So with the kids with Huntington, who we're talking about Huntington's disease, that's a great piece of evidence. What else? Need more than just Huntington's disease. This is a pretty rare disease. Let's go with something else. What about hair color? What about eye color? What's the dominant trait for eye color? Oh, by the way, it doesn't matter where you live. Um, but so a, somebody who's at a two level in standards based grading would have a good piece of evidence, but not enough. That didn't go the extra mile and put another thing in. But just a couple of ways again of um, assessing this. They can do it. They can do it with help. They can't do it at all. I have lots and lots of resources and lots of rubrics that can help with CER and examples that I'd be happy to share with anyone who would like that. You can absolutely send me an email at Kathy Birna, KathyBiernat at gmail.com. And I don't really have any idea how to add that in or link to it, but I'll try to figure that out. Or you can tweet me at Scientist Maker, and that is my Twitter handle. And I certainly am open to any questions if anybody is out there. Um, or I'm pretty much done. So I'll hang in here for a little bit in case anybody joins and wants to add any comments or wants to talk to me. That would be great. I'll just kind of hang here, I think. Oh, hi, Jill. Thank you so much for your comment. I think I actually saw this used in the kindergarten classroom, and it was really kind of cool. The kids, it was in a weather lesson, and so they were trying to get the kids to understand or make the connection between the amount of clouds and how sunny it was. And so they had made observations every day on a chart in their classroom where they looked at the how many clouds was it? A lot of clouds, a little bit of clouds, or no clouds at all, and then how sunny it was. And so then, which doesn't always work because it's hard to tell sometimes cloud cover, but they did a really good job. This was so clever, and I couldn't believe it was being used in a kindergarten classroom so incredibly well. But they made a claim. They said when there are less clouds, there's more sunshine, and that was a great claim. And then they showed their evidence with their chart that they had made, and they'd made the chart as a class, which I thought was again just was just so cool. I don't get out of my middle school classroom a lot, so it was fun to watch these little guys, and they even got to the reasoning, which I thought was great. And they said, "Well, the clouds block the sun." And I thought this was fabulous. What a great way of doing CER with little ones, with little people. I thought that was I was just blown away. I just thought that was really great. In my school, that's probably the only place I've even seen it starting to happen, was in this one classroom. But I was really impressed, and this was a teacher that is a self-professed "I don't like science," but you don't really have to use it. It doesn't have to just be in science. It could be really in anything. They could be reading a book, and you could say, make a claim. You read this book to them, make a claim about how the character is feeling, or what do you think this character should do or is going to do, or did they do the right thing, and give the evidence. Well, they made a decision if they're trying to decide. Again, I'm not really good with little kid books anymore, but I remember my kids used to always read this book about old hat, new hat, and they had to decide which was the best. The little person had to make a claim which was the best hat. Well, did he choose the best hat? Well, the best hat was this beat up old hat. Okay, what's the evidence? Well, the evidence was it fit his head the best, and he liked it, and it had a flower on it, and reasoning. Well, why would this be the best hat for this person? Well, because it fits his head. I mean, I really do think you can do this um, with almost anything. And again, outdoor, specifically said outdoor learning. And then there's just so many observations they're making about the world. And they're making these observations if they're looking at bugs on the ground, they could be making a claim. Wow, I noticed there are more bugs if there's a piece of food that's on the ground. I noticed that these bugs, some of the bugs are bigger than other bugs. I think there's so much potential for little ones they can make a claim for sure. They can get evidence. Reasoning might be tough, but that's okay. If they're making claims, I just think that would be so incredibly powerful. I don't know, did that help? Hi, Derek. Thanks for stopping by. Kind of just hanging out at this point. Um, Talked a bit about using claims evidence reasoning, specifically in a science classroom, although you really can use it in almost any classroom to help kids push them to go beyond just making what I would say a conclusion in a science lab and actually pushing them to understand, okay, this is why this happened. And I think for me as a teacher, it's been a real change because I was used to be pretty content with them saying, well, yeah, this is my conclusion. You know, friction slows down an object and not really pushing them to connect it with the NGSS with the standard. Or what were you trying to learn in this lab? So sometimes kids would say, oh, I love doing labs. Labs are great, but I don't know why we do them. I don't really understand why do we do that lab. It was fun, but I didn't, they weren't making the connections to what we were trying to teach or what I was trying to teach them. And so this claim evidence reasoning really seems to be pushing them to make those connections back to the scientific principles. And I really, I can't stress enough. I think this is something that absolutely should be starting in the younger grades with kids making claims, with kids making observations, and starting to use the terms claim, make a claim. Don't just say, "What do you think is happening?" Make a claim. State your claim. This is it, and it's different than a hypothesis. The hypothesis comes before we've done the experiment, before we've gathered our observations, and a claim goes back to and says, "Ah, okay. So now that I've done this, how do I know? What do I know happened?" So it's more than just saying my hypothesis was proven. It's saying, okay, now that I've gathered the data, this is what I know. And um, this is again, I just think it's such a hard thing for them to do. That the more we can practice this throughout a student's life, the better we're going to do for them. And they don't have to become scientists, they just need to become thinkers, critical thinkers. And I think claim evidence reasoning really, really does um, do that for them. So it pushes them to become scientists. That's why my Twitter handle is scientist maker, because I really want students to become scientists in the classroom. So I've pretty much gone through my presentation, and I'm looking at the time. Um, I just did this presentation at NGSS, NSTA, and so it was a 30-minute presentation. So I talked really fast through this one, but I will hang on in case there are any more questions or anything else I can add. I think I'm going to go ahead and sign off. Um, Pretty much have covered everything that I was planning on saying. Thanks for coming, and I hope you enjoy the rest of your MAD PD session. Thanks.